Now that we've talked about how to visualize the hook methods, the implementation is very straightforward. Hopefully you get a benefit from seeing it both in code and in diagram form. And again, keep in mind that this particular implementation is the one that executed in about 2,000 milliseconds on a multi-core processor. So again, just to give you the big picture, processStream takes the list of works of Shakespeare and then calls processInput on each one and collects it into a list of search results. Here's what the code looks like. processStream is a method. It's a hook method in the SearchStream gang, or the SearchGang framework. We convert the input given to us by the user into a list of character sequences. So we have a list of all the character sequences containing the works of Shakespeare. We talked about that before. This is part of the framework. We get that out of the box. As with the object-oriented example, once again, we optimize this with a character sequence as opposed to a string. And we're going to return a list of search results that will indicate how many times a given search phrase appeared in each of the input strings. Part of the discussion here that we'll talk about later is how we use flatmap to flatten that list of search results into a stream of search results in order to make it much easier to process and collect and group and so on. But we'll talk about that probably next time. And again, it's a search results object. So all this stuff is really the same as the object-oriented version, which is no surprise because we scavenged the functional programming version for the object-oriented version and just replaced the streams with more explicit for each control constructs using the for each loop. So you'll notice here that there are no control constructs. We don't see any if statements. We don't see any loops. It's just a stream. So first of all, the first thing to notice is this is a lot less error-prone and a lot less verbose than the version we looked at that was the object-oriented implementation, where you had to have a loop with if statements. In this particular case, we're going to just have a stream, simple sequential stream pipeline. The factor method converts the list of character sequences into a stream of character sequences. We call the processInput method, which is a method reference. We'll look at that in a second. That takes each input string and searches for phrases. And then we take that and we collect that into the list. Keep in mind that processInput returns a list of search results, one list for each input string. We call collect. That triggers the intermediate processing of these intermediate methods and the factor method. And then we get a list of search results coming back here, which is returned as the result of the processStream method. OK, pretty straightforward, but I think you'll agree that this approach doesn't have any of the accidental complexities that we looked at with the object-oriented approach. In particular, we don't have to remember to initialize the list of search results. That's done automatically for us by collect. So it's a very clean, lean and mean approach, less accidental complexity, much easier to generalize and scale to be multi-threaded and parallel, as we'll see later as well. Let's now take a look at how processInput is going to work as a sequential stream. Again, this is just kind of putting it in context. Here's the visualization. It's got a little bit more processing steps because we're going to filter things in this case. Here's what the code looks like. At a high level, it looks very much like the object-oriented version, but the devil's in the details. We're going to take in an input sequence, split that up into a title and the input of the play itself, which again uses the subsequence in order to be able to optimize and avoid extra data copies, which is cool. Now here's where things look quite different from the OO version. So we take phrases to find and we convert it into a stream. So we take the list of phrases, which are strings, and make a stream of strings. And again, we don't have to worry about initializing anything here. It's done for us automatically by collect, as we'll see in a second. And then for each phrase, we're going to search for the phrase, calling this method. We'll look at this method later. And that will return essentially a search result object for every phrase. And if that search result object is empty, we're going to ignore it. We're only going to allow things to go through that are not empty. And one way to do that is by simply writing a little declarative statement that says, only allow things to go into the next phase that are not empty. So you can just read it straight ahead. And there's no conditional, there's no if statement, there's no conditional branching. It just uses filter to remove the elements that are empty. There are a number of different ways to remove elements that are empty. So this approach I show here uses a method reference and a negator predicate lambda, which is used to negate this result. You could also do the same thing by casting isEmpty to be a predicate and then calling the negate method on it. That's another way to do that. And yet another way to do it is simply to write a little lambda expression that says, for each result, if the size of the result is greater than 0, allow it through, otherwise ignore it. So your mileage, you're free to choose whichever approach you deem most appropriate. They all get the same result, and they probably all run the same way in terms of performance. These are the intermediate operations, of course. They get triggered when collect is called, and in this particular case, we're going to collect things into a list of search results, and that list of search results will then be returned as the result of this, and then that comes back to the map operation in processStream. Remember, map will then take that and collect all these lists of search results into a list of search results. And that's what you're actually going to get back as the final result there. So what we'll do next time is I'll show you some other cool things related to printing the results, and you'll get a chance to learn more about downstream collectors. You get a chance to learn more about the grouping by collector, other cool things.